Hello. Today we're going to be doing some proofs on parallel lines. All right, I know proofs are scary, but these proofs are not as bad, I think, as the proofs that we did before. Before we actually start doing the proofs, we're going to do some review here. All right, we're going to do some review on what the reasons are going to be. You know, kind of the postulates and theorems that we've learned so far. So. The first one, so I'm going to give you some statements, right? What postulate or theorem goes with it. So the first one is angle 4 is congruent to angle 6. So this is angle 4, that's angle 6. And I'm just going to tell you because you're watching a video, but those are alternate interior angles, all right? So this is why you got to know what all their names are, all right? So that'd be alternate interior angle theorem. We've got 1 is congruent to 3, okay? Those ones are directly across from each other, all right? So those are vertical angles. We have 5 plus 8 equals 180, okay? That's 5 and that's 8, so those two are right next to each other, and they create a line, so we can call that a linear pair. We also have 3 plus 6 equals 180. All right, so let's look. That's 3, that's 6. So those aren't a linear pair, but they are on the same side, and they are in the interior of our two lines. So that's same side interior angles theorem. All right, what else do we got? We got 3 is congruent to 7, okay? So those are the ones that are corresponding to each other, right? They're both in the bottom right of their quadrant, so we call that corresponding angles postulate, CAP. And the last one we have is 2 is congruent to angle 8, all right? Angle 2 is congruent to angle 8, so those would be alternate exterior angles. So that'd be alternate exterior angles theorem, all right? So those are all the things that we've learned so far. And we're going to be using those today along with substitution, along with the transitive property, okay? Actually, maybe not, but anyway. So let's do some proofs, okay? So the way that this is going to work is I'm probably going to give you either an angle measure or multiple angle measures, all right? And you're going to have to maneuver through the proof to find a different angle, okay? So let's start. So I'm going to tell you that angle 2 equals 44 degrees, all right? And I want you to find and prove the measure of angle 8, okay? So we have to essentially jump, you know, angle 2 equals 44, so this equals that, blah, 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 all the way to 8. Now this one isn't that long, okay? So we're going to start with our given. All right, our given is angle 2 equals 44 degrees. And now we want to prove angle 8. So how can we get to angle 8? All right, so there's a couple different ways that you could do this. All right, there's not one right answer. I'm just going to kind of show you some examples. So if we know angle 2 is 44, angle 2 and angle 6 are the same because they're corresponding. So that means angle 6 must also be 44. So I'm going to say angle 6 equals 44 degrees. And that would be, since they're corresponding, that would be CAP. All right, so you got to know the names of how you're working through your proof. Okay, now that we know angle 6 is 44, can we get 8? Yes, okay. If you remember, all right, these two angles are forming a straight line, all right, which means they add up to 180. So angle 8 has got to be equal to 180 minus 44, which is 136 degrees. Now, I'm not going to make you write out a whole bunch of stuff in our proof, all right? All we're saying in our proofs are the angle measures. So we're going to finish off with angle 8 and that's going to equal 136 degrees. And we can say, because they make a linear pair, okay? And that's our proof, all right? So because angle 2 is 44, we know angle 6 is 44, and thus angle 8 is 136, all right? So hopefully, you understand this stuff. If you know these things up in this table, you should be able to get these proofs. I know you could tell me angle 8, but we're trying to prove it, right? We're trying to have reasons that support what we say. So that would be angle 8. Next problem. So we're going to do a couple of these, all right, just showing you some different ways that it could look. For this one, we're given that angle 1 equals 89 degrees. That's our given. So I'm going to write that in. We've got 89 degrees. And what does it want me to prove? It wants me to find and prove angle 6. Okay, find and prove angle 6. So again, there's multiple different ways that you could do this, all right? The way that jumps out to me doing it, recording this video, is that if angle 1 is 89 degrees, that must mean angle 3 is also 89 degrees. So I'm going to say angle 3 equals 89 degrees, and that would be vertical angles. Okay. And now, if I know that angle 3 is 89 degrees, I can get angle 6 because I know that angle 3 and angle 6 are same side interior angles, and I know those angles are supplementary. So if I do 180 minus 89, I get 91 degrees. So I know I know 6 has to be 91 degrees. And that would be same side interior angles theorem. So we'd write our given down. For what play? You want to put that in today? Let's go for it. Did you ask him about Izzy? Sorry, guys.
No, I'm going to.
Okay. Sorry about that. We had a little interruption there. So what I was doing here was writing this down. Angle 2 would be 75 degrees. Okay, so if you look here, this is a little bit different, but still a linear pair. All right, this is just 3 angles making a linear pair. So I know that angle 2 is 75 if 3 is 57 and 4 is 48. So I'm going to say angle 2 equals 75 degrees, and this is still linear pair. Okay, they still make a line. So even though it's not technically a pair, the thought still counts. Okay. So by the way, what am I trying to prove? Angle 8. Okay. So I got angle 2 equals 75. So I'm trying to get to 8. All right. So what I'm going to do is I'm going to jump through, all right, to 9. So I also know that 9 is 75 degrees because it's vertical with angle 2. All right. So I'm going to say that angle 9 is 75 degrees, and that would also be vertical angles. And now, can I get 8? I can, all right? I can get 8 because 9 and 8 are corresponding, right? So I can say that angle 8 is 75 degrees. That would be cap, all right? Corresponding angle postulate, because 8 and 9 are the same. And actually, why did I put so many steps on here? I don't know. We did it in one less step, guys. Good job. 75 degrees. That would be cap. So look, there's more than one way to do this, all right? There's a bunch of different ways. When I made the table, I was probably just thinking of a different way that I did now. But that's all right, okay? We got it in one less step. If you can do it in one less step than me, good job. Last one, challenge proof, all right? I'm gonna show you kind of a long one, all right? But that's okay, you guys can do this, all right? All you're doing is just following through your proof. So we're gonna start out with here, so this is kind of a weird given. So they told us that C is parallel to D, all right? That's what those two vertical lines mean. They mean parallel. They also said the angles shown are 72 and 120. That's kind of a weird thing to write, so I'm actually not going to write that in the proof. You can get it from the picture, okay? We're trying to prove the value of Z, though. Where's Z? All the way over here. So somehow we have to get from all the way up here to all the way over there. So what I would recommend is just start writing down what you know, okay? Everything that you know. So if that's 72, I know H is 72. All right, so I'm gonna write H equals 72 degrees, angle H. All right, what else do I know? I know if this is 120, so P, all right, I can get P because that's a linear pair. So 180 minus 120, that's 60. By the way, I didn't write vertical angles here. Got a little bit ahead of myself. Angle 3, or sorry, step 3. So I said what? P is 120. All right, and that'd be linear pair. Now this is one that we didn't talk about as much. All right, but we have talked about it, but I made sure to put it in these notes. And that's actually the triangle angle sum theorem. All right. The angles of a triangle add up to 180, okay? So I know that K, H, and P have to add up to 180. And if I already have H, oh my gosh, this isn't 120. That's 60, my bad. I said 60 when I first said it, I think. I was gonna say, because I was about to be wrong, okay. So 180 minus 60 and minus 72, that should give us K. So I'm gonna get my calculator out here. 180 minus 60, that's 120, minus 72, that's 48. So we know that K is 48 degrees. And that is triangle angle sum, okay? Okay, what else do we know? So let's just keep going, all right? What else do we know? So if K is 48, then M must also be 48 because they're vertical. So I'm gonna say that. Wait, that's not what I meant to say. I'm gonna say M. M is 48, and that's vertical angles. And now what can I do? I actually can finish here. Yeah, so if M is 48, then I can use corresponding angles to say that Z is also 48. So we actually did this one short as well, but that's fine. So Z is also 48 degrees, and that would be cap, corresponding angles. So this would be like a tough problem, all right? But if you're able to follow it, all right, you should be able to get any of these angles, right? I could ask you, what's Y, W, X, S, T, V, U, and hint, hint, if I was making a test on this, which I'm not, so don't actually listen to this hint. I might put this picture, on the test and maybe ask you T or something. I don't know. But this is how you would do this problem. So go ahead and try the practice, right? The practice is exactly like this, all right? You're just kind of going through your picture, stating what you know, and giving your reasons. So if you have any questions, let me know. And other than that, have a great day.